Welcome back, reinforcement learning subject. This session I explain the solving multi-arm bandit problem in focused on balancing exploration and exploitation. Okay, in this session I explain introduction of the multi-arm bandit problem and problem formulation and explain of the what is the exploration and exploitation and strategies for balancing the exploration and exploitation and implementation and conclusion. Okay, here multi-arm bandit problem is a basic reinforcement learning concept. It is mainly we are using for making decision in uncertainty, uncertainty. It is the main objective of the multi-arm bandit problem is to maximize the cumulative reward. It has a multi-arm, means it is like a casino type of game. It has a number of missions. Each mission has their own payouts, different probabilities of the payouts. So we are the main objective is to get the best payout mission. Okay, we identify the best payout mission. That is the objective of the main objective of the multi-arm bandit problem. The multi-arm means we have the number of arms and number of missions. Each mission have their own payouts. Okay, different probabilities of the payouts. So the multi-arm bandit problem is the basic concept of reinforcement learning. It is used to take the decision of the uncertainty. So here the problem is which action means which mission we choose, that is the best payout mission. That is the main problem formulation. Okay, here we take the action means each action correspond to pulling the lever of the one of the mission or one of the mission slot, and reward. Each mission have their own payouts. So when you pull out the mission, we get the some payouts. Okay, our main objective is to maximize the cumulative reward by identifying which mission has the highest average payout, That is our problem definition in multi-arm bandit problem. In multi-arm bandit problem, we need to balance the two strategies. One is the exploration, second one is exploitation. Exploration is to find out the new missions payouts. We find out the new we involve the trying out different mission to collect the information about that mission's payouts. That is the exploration. Exploitation is we have the knowledge. Okay, we have the knowledge means we have the mission's payout values. We choose the best payout mission is the exploitation. Involve choosing the mission that has yielded the highest average reward. Okay, that is the exploitation. Exploration means we find out the new missions payouts, and exploitation means highest payout mission means find out the highest payout mission. That is the exploitation. Exploration is acquire the knowledge to open every mission and find out the payouts. Exploitation is what the knowledge we have, what are the missions we are opened, based on knowledge or based on that information we find out the best reward mission. That is the exploitation. Okay, in strategies for balancing the both exploration and exploitation, we have the several reasons we are considered here. The first one is decision making metric. Which metric it is the best metric to take the decision is, in this example multi-arm bandit problem, the average payout is the best evaluating metric to find out the best mission, to find out the best mission, to get the best payout. The average payout is the key metric for this one. The learning from experience. Learning from experience means we open the missions and find out their payouts. Based on that payouts, we choose the best mission. Okay, learning from experience. And each time we get the knowledge, open the different missions and refine that knowledge of the corresponding mission. That is the learning from experience. and balancing both exploration and exploitation is important. Every time we open the exploration means we are not get the good results. Every time we are focused on exploitation, it is also not give the good results. So we we maintain the balancing both exploration and exploitation. Okay, risk assessment in best reward or best payouts missions will always not give the highest scores. They sometimes the variance of the payouts values also very large values. Some very high variance also happened in best payout missions, and some lowest payout values maintain some consistency. Some cases we also balance that situations also. And algorithmic development, we consider all these balancing both exploration and exploitation concepts. We to build the models. Now the one of the strategy for balancing the exploration and exploitation is greedy strategy. The greedy strategy is completely focused on exploitation. Exploitation means it always open the which mission has the highest payout, it open that mission only. So it is always focused, there is no exploration, it is completely exploitation concept. So in that case we miss the some untrialed missions. Untrialed missions may have highest rewards, those missions we miss in greedy approach. So we go to the some best approaches, epsilon greedy approach, epsilon greedy strategy. In this epsilon greedy strategy, the less time it is focused on exploration, more time it is focused on exploitation. In epsilon means the small probability value. We define some small probability value like a 0.2 like that. That probability time it is focused on exploration, find the new missions payout values, and the probability value 1 minus epsilon it focused more on exploitation. It is open the highest average reward, highest average reward bandits. It open the highest reward in 1 minus epsilon times, and epsilon times it is focused on exploration, means find the new missions values, and already existing open values find the open values. Exploitation is focused more in epsilon greedy method. Exploitation is focused more, exploration focus less in epsilon greedy strategy. Okay, this strategy we are using where exploration is very cost, that case we are using we are focused on epsilon greedy strategy. Okay, one more strategy is softmax selection policy. Softmax selection policy, it is a probability distribution based policy which mission has the highest probability, highest reward, that has the highest probability value. Which mission has the less payout value, that has the less probability value. The probability of all missions, the sum of the probabilities of all missions is equal to 1. In softmax selection policy, like a softmax activation function. The softmax selection policy, in that highest reward mission has the highest probability. We in exploitation we choose that probability mission to get the best payout. Okay, these are the different approaches, different policies to balance the both exploration and exploitation. Okay, these strategies are we are using for in multi-arm bandit problem, like means the multi-arm bandit problem means these strategies we are using to make the decisions in uncertainty situation. Uncertainty situation means we don't the probability trial and error situation, we are applying this type of strategies. Okay, balancing exploration exploitation, it gives the best reward, best results in multi-arm problems. These strategies will help in uncertainty decisions in different applications like online advertising, placements, and clinical decision making applications. We are using this type of strategies. In this lecture I explained what is multi-arm bandit problem and what are the key concepts in multi-arm bandit problem. Is the multi-arm bandit problem is the simplest reinforcement learning concept. It is used to make the decision uncertainty. In this we are using exploration and exploitation. Exploration means find out the new new values, and exploitation means among we have the knowledge, on that knowledge we get the best one is that exploitation. And what are the strategies to balance the exploration and exploitation? In this class I explain epsilon greedy and sort max. Okay, next sessions explain the more epsilon greedy method and sort max methods. Okay, thank you.